Hello, I'm Roshan recording experiment 1 and this is our first experiment and the first question is to import a data set with missing values and store the data in a local repository. So first I'll show you how to import a random data set. So what we have to do is I have a data set here called wine quality and I drag it and drop it in the left panel of the rapid menu and it will pop up a window and in the window you have to pick what is the separator. The separators are basically how each columns are separated in the data or in the imported file. So in the CSV file it's usually comma, but you can see since they don't have a comma, the RapidMiner is detecting it as a single attribute, all the information as single attribute. So this is important to set the right separator. Then in here this you can set the type and the role. Type is basically what type of data is the attribute. So sometimes RapidMiner doesn't need it right, or sometimes you want it to be as a string, though it's a number. It's so you can change it here. Then to change a role, you can set an attribute's role as an ID, or you can set a weight, or you know to set it as a label. So it's important because when you are classifying something and sometimes if you're giving the ID attribute into the classifying algorithm, it's going to give a result, but the right result because uh, it's easier to classify something with the ID. So when you give the when you mark them as ID, that the role it wouldn't be used in any of the classes if the classification algorithm neglects it. So you get a better results with the which is generated using all the other attributes. So yeah, now next you can pick where you want to store it. So according to the question, we want it in the local repository, and in the local repository, we are going to put it in the data folder and finish. So this is the data set we just imported. Now let's see the next part of the question. Next part of the question is explore different methods of replacing missing values. So we have a direct operator for replacing missing values called replace missing values, and let's see how it's done. Yeah, okay, let's see the data set for that. The data set, this is the imported data set and it has a lot of missing values. And let's see how it is fixed by its operator. In the operator, we can pick what method, using what method you want to replace a value. So you have minimum, maximum, average, zero, or value. So you could set a specific value you want, that is value, or you could put zero in the places, or you could take the average of all the values in the data of that particular attribute and replace the missing values with that. So let's try this. You can see here all the question marks here has been replaced with some value. Here it's 40 and here I guess it's 1. That's that. And the next part of the question is to derive a new attribute using a mathematical expression. So let's see the data set before that. And it's a player data set. It includes information of the player name, ID, his birthday, his height, his weight. So here height is in centimeters and weight is in pounds. So what we do here is we use the attribute called generate. We use operator called generate attributes, and in that you can set what is a new attribute you want to add and how do you want it. So here what I'm going to do is I'm going to take the power of height divided by the weight in kgs here. This is basically the BMI, and once you have it applied in the result you will see a new attribute called BMI. And yeah, the range is not actually right because the formula is not proper. So anyway, this is how you add the BMI. Then the next part of the question is to transform the data using min-max scaling of numerical attributes, or equal frequency and equal with binning of continuous attributes. Okay. For scaling is basically normalization. Normalization is scaling the data to two values. So you could actually decide how do you want to scale it. So there are different methods of scaling: the range transformation, proportion transformation, and interquartile range. You could pick which you want. So for range transformation, you can pick what is the maximum, the lower value, and the highest value of scale. So here we have 0 and 1. Let's see. In a normalized, the result of a normalized data set, all the nominal or polynomial attributes are ignored and the continuous values are brought between values of zeros and 1. You can see here the entire data set has values between zeros and 1. And the second part of the question says to do binning, discretization. So discretization is a technique to convert a um, numerical values of an instance to a nominal one. So there are two techniques. One is discretization by binning, the other one is discretization by size. For discretization by size, in the parameters you can set the number. Sorry, discretization by binning, in the parameters you can set what is the number of bins. So basically, the entire data in the attribute are going to be uh, divided into bins, and the number of bins is constant. So there will be 10 bins for how much ever the number of instances are. The number of instances is going to be 10. And for discretization by size, we have the number of instances in a bin constant. So the number of bins here vary, but the number of the size of each bin to the maximum is 10. So with that, and the last part of the question says to compare the result of previous question with histograms. So all you have to do is go to the results, discretization, and go to charts and pick histogram. That's it. And here number of bins. Okay, I lost it. Let's try the other one. Yeah, this is it. You could also change the number of bins here, like to show the difference. It's basically equivalent of changing it in the dataset, in the parameters before performing and before giving the start value. And that's it. Thank you.